Hello everyone, another advent of code, and I will admit that this is probably one I like the most up until now, but probably because I got really good solution, time-wise at least, not leaderboard-wise, but execution-wise. So let's go through the task, and the task is that you have those shapes, kind of Tetris shapes, and you play Tetris, right? So those are shapes you would get, and in our implementation, they are going in cycles. So first this shape, and it circles around, and then this is input to our Tetris, right? So first right arrow, right arrow, right arrow, left arrow, and this also cycles, like indefinitely. Our Tetris board is 7 units wide here, and it is infinitely high. This is the only concerning thing you need to keep in mind. And because of infinite height, you may go out of memory if you try really trivial solution. And also the other problems with part 2, but first we are starting with part 1. So here this is an examples. The shape always starts with left bottom corner being like 2 tiles away the left side, and the 3 spots away from the highest shape or highest occupied tile in the whole Tetris surface, right? So it looks like, you see this rock is first, this shape is first spawned on this position. We start with this shape, and then our first input would be right in this case. So it is pushed right, and then it goes down. It also pushed side, fall down, push side, fall down. If shape hits either a wall or another shape while moving right, left, it cannot go further, it is blocked. If shape cannot fall lower because any of those tiles would hit either bottom of the tower of the Tetris surface or another block, it freezes. It is fixed in the position. Like here, it's fixed. Just go step by step here. Now it was pushed, blocked, falls, and then pushed, tries to fall, cannot fall, is fixed. Right? Those hashes means fixed. And when it is fixed, new block is spawned immediately in the same exact frame. So this guy was pushed in this input frame, let's say, and this would be pushed in another immediately, and then it falls down, right? And this is animation of several types of the test input here. And we have some examples that will be very useful for debugging. I mean, I already solved it, and I would just go through solution. So yeah, we have Tetris. And then the question for the first part is, after 2022 rocks are fixed, how high is the tower? This is the question. And the solution for that is very simple, and I will not go through the simple solution of that. I will already go through solution for part 2, kind of, but I will tell you what could be simplified maybe. So let's go to day 17. And our main function. So first of all, I needed to define our shapes in some way. And the easy way to define those shapes would be something like constant shapes. We could build this as an array of arrays, and every array would be another array. And let's say this would be bool, right? 4 and 4. We could do something like this, or just bool fit 16. Doesn't matter. In cases like this, when we are not working with vectors, but we are working with arrays, there is no benefit of going with a flattened array. And the reason is this is anyway continuous memory. For vectors, it's not always exactly true, because every vector is another allocation. But in this case, we can just go this way, and it would not affect us negatively. And we could do something like this, and we could define our arrays like, you know, every row being a row of the shape, or we have four because this is the biggest window we can have. And this is basically what I went for part 1, because I didn't want to premature optimize. But we can do way better in terms of performance by picking proper structures. So we will make our shapes being sizes of uints, and every uint would define the row. We are going from the lowest row with the lowest indices, so the 0 index defines the lowest row, and the next indices would go higher, and the row, in every row, the lowest bit identifies the left position of the shape. So we have eight position to use. We need only 4 on the most complicated shapes. So for example, let's see, for the first shape, this is this straight line. It is just single row, right? And going from the left, bits go from the right, because we need the less significant first. So we go 1 1 1 1 4 ones, right? Next shape, 0 1, because we go 0 1, and then this is 0, which we don't care about. We can skip, right? Second row, 1 1 1 1. Third row, 0 1 0, which I can skip here. And this is better. The most important reason this is better is we are compressing basically those booleans into unsigned, and it would be way better to detect collisions. When I would go into detecting collisions, I would tell you why this is so much better. And also we save some space, but the space is not important. The important thing is that when we would work with this shape, we will not check 4 rows, we will check only single row, because we know how high is it. And we can do that because instead of storing the fixed size array for rows, we just keep here a static borrow to some constant shape, and it would work in Rust. Right, so all of those shapes can have different number of rows, and this really saves us not on the input size, which on the data size, which yeah, a bit, but it really doesn't matter, because you have only one shape at the time, like alive. So memory doesn't matter at all. What matters here is the complexity of checks. It helps a bit, or even more than a bit. And then we have collision detection, which is one of the most important things in the solution. And there are 2 collisions we do not detect in the function. The first collision is going beyond the left border, because going beyond, we are working with uSizes here, and I didn't want to cast between uSize and tSize all the time. I could, this would be also a possibility, but I just decided that whenever I try to decrease x or y below 0, I would just like early decide that there is collision, because if I go below 0 with my left bottom corner, it's collision, which is trivial to find, and the same is about y. So I do not detect the collisions with the floor here, because it would be detected by y going below 0, and we are going with my x left to right, and y, this is important, bottom to top, which is kind of intuitive, but this is this might go both ways. So this is important, it goes bottom to top. And first, checking the right edge, and conveniently enough, we have only 7 spots height on our Tetris, because this gives us this thing that if we just go too far, then we just too far, right? So first of all, how do I move because this is important, how do I move the shape? I mean, if I move my bits left, so in the direction of higher bits, I need to move every row left. Then what I do, I actually move my piece right. And the other way around, so if I move right, then I can just move my left, but I just always, I never move my actual piece, I just calculate the position using this x coordinate, so I, like, if x is 0, this is piece touching the left side, and I would just shift it with x-axis to find the position. I never go 2 steps, which is also helpful, so I can never skip this collision point. And if I if I move the piece, so any bit after movement makes a 8-bit being 1, I have a right side collision, and this is the situation. Here are 8 sevens, 7 ones. So if I am bigger than 7 ones, then I know that I just lighten up the highest bit. I could just do like also like 1 with zeros, and then just if this and this 1 0 0 0 0 and this is more than 1, this would also work. But this is one way to check on that. And yeah, if this happens, then there is a collision. And now there is way more interesting way of checking collision with a surface. So with our fixed blocks, basically. How do I do that? First thing is actually this. So I am taking cutting the first y lines from the bottom out of the surface. So what I want to do, I want the surface to start on the row where my shape bottom is. I want them to align. I ignore anything which is below my falling shape here. This is this y dot dot. This is subslicing, and then I just zip it with shape, and I would have only as many positions up as many lines in my shape. And now I have my line I am considering here, and I have my shape, but my shape is not yet moved. Then I move it to proper position with shifting, right? I shift my shape right by X to position it, and I check if anyone aligns with any line one on the surface. This is what logical end does, right? So if my shape is like let's say I work with square, and this is my shape, so 0 0 5. Okay, this is my line of my square, and let's say my line is this would be number 1 2 3 4. Sorry, it would be, let's say this is how my line is looking like. So if I am on, and this is obviously the left border, right? Because we need to think about the split, because less significant bits are left border. So let's say this is a situation, my x is equal to 0, so I just compare those guys. So if we do logical end of those, right, then this bit is 1 on both sides, so it is at the end I get something like this. So because a bit is up and a bit is up, this is more than 0, right? If I would try to move it, let's say 2 spaces, so let's go 2 places, because my x is 2, something like this, right? Now I get this, right? But if I move it another 2 spaces, then there is no collision, and I can basically go lower. You know, this is how I detect collision, and I just need to find if there's any line which collides. So in those range where shape is on the bottom, and this is how you define collision. And this is the most benefit of keeping our shapes in this form, and also surface is kept in the exactly same form, except we would use the full 7 bits of full, it's 8, but 7 bits of our surface here. If you would use just Boolean array of 7 here, 4 here, or whatever, then I would need to check every Boolean separately, and it would be way slower. But this is still not the best performance improvement in this part 2 solution, but we don't care about part 2 yet. So there's a push function. What push function does? Push function takes me direction which I want to push into, and then it takes my shape, it takes my surface, and it takes my positions, and it returns me my updated X position. So I just took it to another function to make it like a bit easier to maybe think about. So what is the definition of that? If we have direction being right arrow, we need to increment X, and we can always increment X, sorry. And if there is left arrow and X is more than 0, then I can decrease X, and that's okay. But I don't return that yet. I just store it as some new X. If this is covering the situation, if I go left, but I have X being 0, and in this case I know I immediately can return X. I early detected the collision with left end of my surface. So now I check if there is collision. If there is a collision with new X, note that I'm passing new X, not old X, then I need to return the old new X. I cannot move, it's blocked. If there is no collision, I just return new X, and fold is basically exactly the same function. The only difference is that for Y equals 0, this is the only thing I need to consider. I immediately return 0 and true. True is this additional information if there was collision, because if there was collision falling down, I need to do additional stuff. I need to fix the position of my shape, and I need to spawn another shape. So I'm returning this information if I went down or not, right? And if there is collision, obviously I return old Y. I test the collision with Y minus 1. Here I don't need my new X because it's always the same, so simplify it a bit. I test collision with Y minus 1, and then I go with true. Either is a collision, I return old Y, and there's collision, right? Simple enough. And the fix is the last helper function. It takes shape, it takes the surface mutably. The surface is mutably because I would like bend this shape into its position. I assume it should be there, and I do it very simply. I just take, this is very similar to what I did in collision. So I take my shape, I take my surface, but starting from the shape line, from the line where it's shaped, I ignore any lines below. It would obviously use only as many lines are in shape. I iterate between those like in parallel, right? S is my shape, so it's my surface, and this is logical OR operation. So logical OR is like making sure that bits which are ones in this expression, and we already know this expression. This is the position of this line. This is this shape part, the design part of the shape, let's say, and we just making those bits ones on the surface. This is just logical OR, right? So let's say our line is something like this, 3, 4, 5, 6, 7, and my shape is something like, we can go with square again. This is not possible situation because we will not file this low, but let's say we have X equals 3. So we have this situation. So this is logical OR would make this line something like this. Sorry, 0. right? And this is how I fix my shape on my surface. And those are my helper functions. I would show you another one which I don't use in solution. This is why it is unused, but it proved to be very, very useful in debugging. So what I do here, I just look for the highest row which contains any fixed positions, and I know that row contains any fixed position if it's more than 0, basically. If there's more than 0, then some bit is 1. And I make it +8 because I make it +8. I just want to have something above it so it's easier to read. It doesn't matter at all. I cut it to the surface height for convenience to not check if my indexing is proper. So if I have not enough spaces above, then I would cut it. And then I go through every row. They is Y offset, right? In reverse, because I want to draw from the top and my 0 is my bottom. And I go through every bit I am interested in, 0 to 7. And what I need to do, first I check if this bit on surface is high. So I just do end with 1 shifted p times. If it's high, then I print fixed position, occupied position. And then another thing I do, I check if this could be based, by the way, x plus shape.len, but I completely did not optimize this function. So, or not? Not. Actually, not. It cannot be shape.len. Cube, I can go with shape.len. So I check if my I, so I is my x position, is the at most 4, right? But it's something between x and x plus 4, basically. This is the only case when it may highlight my falling piece, yeah, and my y is in the my j is in this range of y, and I do this only to avoid any kind of overflows on this shifting, and especially on this shape j minus x. I just want to avoid overflows, and I just shift those guys. And if it's high, so x shifted and position shifted, then I know I can print falling piece. Anything else just dot to make it visible, right? And I end my line every line. So this is helper function, which is not used in a final solution. We completely ignore state for now. This is part 2 thing. This is steps 2 is also part 2 thing. I didn't do 2 different functions because they would be exactly the same, like precisely exactly the same, except first doesn't contain caching, and basically solving steps 2, I would have steps 1 calculated in the process. So I just took one function and I'm not returning value. I'm pretty good like the value. This is very poor habit in terms of software engineering, but if you are doing this because you know you are solving puzzle or you are running one-time script, you can do that. I mean, we already went through all the simple puzzles. Now, instead of focusing on doing perfect software engineering, we focus on solving puzzles. And puzzles are very specific things. Those things you completely ignore. This is only because I wanted to check if I am faster than my colleague with the solution. I will not tell you that. And those are results, calculated results, and I don't print them immediately because printing takes time. And I particularly don't want to print part 1 solution because I'm still calculating the second part, and I just want to avoid wasting time printing. So this is very, ignore that. And now this is something we don't like. We don't do that in Rust, but there is good reason why to do that this way in Rust. So there is another way to do that, you can just take all of that into your fold. Or you can create a structure to keep all of that and then pass the structure in the fold. And in general, I would prefer this solution for production code, except it's not a production code. And this is often easier to maintain this way. So we create some surface. We make it of some height. Surface is obviously a vector of UI. And the question is why I started with this height instead of the lowest I can go. The lowest I can go is basically 4 because my first shape is spawning 4 pieces ahead, above the 0 position. But the thing is that I know for the fact that I need some height. I mean, it's reasonable. It's reasonable to think that I can do first part without any relocation, and that's why I picked this thing. So I'm sure that my vector would not relocate or not do any strange things on the first couple steps. I don't even know if this vector relocates. I have not, but this is something you can tune for your solution speed. I just decided it to be steps 1. I could also do something like vector with capacity, then make it with capacity steps 1, and then just add first for things for all the functions like push and so on. Sorry, those above. I really need this to have at least as many elements. So my spawned shape is on this, because my collision function, for example, would just assume the other. But maybe the new implementation doesn't care actually. So maybe that's not true for the new implementation. Okay, next shape I would spawn. I need to keep it somewhere because it would change. My current shape, I just take the shape and I copy it. They are very light, and they are just borrowed, right? So they are very light. My current position, XY, I could do it more sophisticated, but there's no point. Fixed count. So this is number of shapes are fixed on the surface already. I need to count this. I mean, I could just generate it via iterator and then call count on it, but this really is the easiest way to do that. And then remove lines. This is something I am wondering if I can just remove. But I would, because this was the memory optimization, the memory write optimization. But this was because I thought that it would be enough, and it turns out that the important optimization has to be done for second part, and that could be a case that this whole thing can be removed, and it may make solution a bit faster, because we will never do costly copy in our vector. I'm pretty sure that's true. Because I actually know when I find the cycle, so yeah. But I will tell you what is this optimization about, and I would remove it at the end to check if it helps with performance. So removed lines is the thing. When I have my entire line filled, then I know that nothing would fall below this line, right? So what I can do is, so you know that my vector would grow and grow because I have infinity high Tetris surface. So what I can do, I can remove this line and all the lines below it, because I know they would not affect solution, because nothing could fall below this line. Technically it's impossible, but then I need to keep this information how many lines are removed, because I need to remove it to add it to my tower height. So this is my removed lines, and my top is my position of the highest the tower height, basically. So this is the first position where is nothing there. I could always calculate it, but the calculation of it is linear in terms of Tetris height, and I can just track it. And all those things like top, like mostly top. The top is just micro optimization. You can calculate it on the spot, but you can track it, which is way faster because calculating it every time is linear in terms of your tower height, while keeping it is constant. You just increase it every time or decrease. And then we have hashing, which we will we'll completely ignore for part 1. This is very important. The most important thing is the solution for part 2, but ignore it right now. So what do we do here? Ignore enumerate and ignore index. I mean, they are not important. For the part 1, only direction is important. So direction is our input, and maybe go quickly to main function. Our input loading right now is just reading line. It's all. And then I filter input to get only those characters and those characters. Basically what I'm doing, I'm removing the last new line because it caused problems because this read line added this new line and my input was invalidly cycling. So this makes sure that there are only expected characters in my input, but it could be just remove last character, doesn't matter. So this is how I read my input here. My input is single line, and now I go through every character of this line. And first of all, I always and the cycle. The cycle is the iterator which makes your iterator just cycle infinitely. So infinitely I go with direction, and I push my shape in desired direction. Yep. And then I follow my shape, having my new y and spawn, and I destructure the tuple, and then I just overwrite my y because this is my new y position. And what I then do, this is the crucial thing. What happens if I spawn? Let's keep this whole thing for a second. Let's go to the end of this. And as you can see, if I don't need to spawn, then I basically go to next iteration. This is all I do. And now spawn. If I need to spawn first, I need to fix my shape. And then I calculate my new top. So how do I do that? Because I don't use any like fixed size array for shapes, I can use it because now I know that my shape length is exactly its height. And my y plus this length is the new top if my shape is new top basically. And I just update the top to being maximum old top, and then the other thing is the top of my new shape, right? This is easy. Then what I do, this is something I can probably remove, and this is removing lines. Or can I? I can do it too. So what is this? It just checks if there is any surface which has exactly if there's any row which has an exact percentage of this, but I don't need to look through all the rows. I am just looking for as many lines as I have my lines in my shape here. So those are indices. And then I just offset them by y to check those values. I probably could do it a bit differently, but it doesn't matter. This is good enough. Oh, I couldn't because I need to drain. So I look if any of lines I fixed my shape, because only those lines could became full. Is this full? And this ref is kind of important because I want to cut it as high as possible. Okay. Oh, removed. I cannot remove removed. I know why. I will tell you later. Why I can't, but I can remove this drain. So what this drain does, it removes this range of elements, which is basically from the very beginning up until the line I just found. I just remove them, but drain returns me those elements in the iterator. And this drain is actually very expensive operation, surprisingly expensive operation, which I can get rid of. I just need to know how many lines I'm skipping here. And then I just could add removed lines, and I could move the top, and I would need to keep my bottom, and all the time I would need to work on the surface bottom. And why I cannot remove this, I need to keep track how many lines I remove for caching. I don't see a way to completely remove this tracking, but it doesn't matter. But I know that my friends actually don't keep it, so there is a way, I just don't know it. So shape. Then I update my shape to the next shape. I update my next shape to next shape plus 1 modulo, because I would cycle. I need to spawn it proper position. Always x is equal to 2 on the spawn, and y is always the top position plus 3. And then I need to resize my surface, because it may be a case that my surface is too low at this point, because tower is going up and I need my thing to be at least so my shape can fit into it, right? So I resize it to this height, and then 0 is my. I know that there is nothing above the top, so it's safe to do that. So to this resize in terms of shrinking, and shrinking is basically doesn't hurt us because it doesn't relocate or nothing. This is it. This is new value to add if we need to grow it. This is the only thing. We add the shape we just fixed in, and this is caching. We ignore that. We ignore all of that. This is part 2. We can live with that without that completely for part 1. Fixed count, and fixed count is how many steps we've seen, how many bricks we fixed, right? If it's whatever we have for part 1, then we just make our solution being our top position plus how many lines we removed, right? And if you remove this whole caching, if you remove this, let's do this, you will get your on release build. Oh, I don't even get my solution quickly. Let's do this. So you will see that you will get your part 1 solution like in no time. It's very fast, but I mean, you don't want to wait with me for the second solution this way, and this is because the second part is exactly the same, except you need to fix that many shapes, which is kind of much. And you will, first of all, you will run out of space if you try to grow it infinitely. If you will remove this cutting lines right now, then you very quickly go out of memory. Like, I can do that just to show you. I just remove that. Okay, it takes some time because I optimize my surface. But you will easily go out of memory, just growing your vector, and you will never get your result. But there's the thing that our surface is pretty small. And what's more important, both our shapes and our input cycles, it is a cycle, which basically guarantees that we will have this cycle of states, that our situation on the board plus our input, like not like left right input, the index of input we are considering, so the position in our array is precisely the same. And this is the state thing. Right now I am using a bit better state, but it is not obvious that why it works. So initially my state was this, and I kept the board from the lowest, lowest position which I keep in my memory. I have my next shape, which is next shape I need to spawn, because if I have the same position and the same input but I spawn different shape, this is not the same position. And my input position, and what's also important kind of is that, by the way, this worked. It's not that it didn't work, it was a bit slower that I was experimenting with the best solutions. So yeah, I have this state, and I cache the state not with every frame because it would be kind of too often, and also it would require me to basically cache the position of falling piece. Instead, I cache this every time I fix well, how it's called, a piece. And now here I have something like commented also. This is how I created the old state. If we would do this for a second, I didn't keep hate then. Now hate is just keeping the board. So what I did, I just removed any empty lines on the top. I probably don't need to do it because I actually shrink it. Maybe not. I don't know. I try to minimize the size of the surface, so I just remove any. What I do here, I search for the last row, which is just 0. I mean, row which is just 0 is row which I just can get rid of from top, and then I just shrink the surface. This is like the I is the first row which is not 0 from the right, and I keep it as boxed slice, which is a bit better than vector performance wise because it doesn't need to keep capacity. It doesn't matter, like I just know it's a bit better, but it would not affect probability times at all. And I keep shaping in position. Because of that, I created this new function, so I don't need to do it inline. But it turns out that it's good enough to store here your tower height. You don't need to store the entire state, because if you think about that, if you have your cycle, then it would be just one tower which would just build up, and everything which is on the side, just every other like columns grows slower in this cycle. And because of that, it turns out that what you really need to find the cycle is height. It's not obvious why it's not enough, because you need to very closely analyze what could happen to understand it, and I am not fully sure if I know why height is enough, but it is. I mean, if you want to be sure, you can just go with board, and board is very easy to figure out, because if you have exactly the same board and the state, then it would behave exactly the same in cycle. At least for my input, those states finds the exact same cycle. So I'm pretty sure height is enough, just because I've seen other solutions and they also use only that. So right now, caching. What did I omit before about caching? The states. Something I omitted. So I keep for every state how many lines did I remove till now, and how many. What is it? I don't remember order, but one is how many lines are removed, and the second is how many shapes did I fix in this cycle. I mean, it for sure will be some multiplication of 5, but it could be 15 or 1700 or something like this, which in my case is 1700. Okay, so what did I skip here? Let's think. I skipped caching. So I create my state, right? This was creating the previous state. I needed to pass surface instead of top. So I pass those. And what I do, I insert my state into cache. Which means for this state, I insert how many lines I removed up until now and how many shapes I fixed. So I know that when I meet the exact same state, then in between those the position times, those steps, I removed the difference between removed lines and cached removed lines, and the difference, and I fixed difference of what I fix now and what I fix this time. And conveniently enough, for hashmap or for hashmap, insert returns you previously stored element in this entry, right? So what I do have here, I just try to deconstruct previously stored element. If there is something, then it means I got a cache hit. If there was none, I have a cache miss, and I just go forward. What do I do if I have cache hit? I calculate my cycle length, so how many shapes I fix per cycle. This is how many things I can fix per cycle. Then, how many lines I remove per cycle, because state I assume is exactly the same, right? And then, how many cycles left? How many shapes left up until next checkpoint? And I have 2 checkpoints, step 1 and step 2. And the thing is that it may happen that the cycle is detected before steps 1. This is not needed. I could just go with steps 2 minus fix count, because I just checked when the cycle is occurring, and is after steps 1, at least for my input. But this would work, and it would first try to reach the steps 1, and after it breaks through steps 1, it could immediately detect another cycle. Basically, because of how cycles work, if I hit one, if I hit my cache, then with every single fixing position, with every single basically cache test, I would hit my cache, and I would be on the cycle, on the very next element of the cycle. The thing is that up until I reach the steps 1, I would not have enough cycles to get advantage of that, but immediately after I would reach the steps 1, I would hit another cycle, which would bring me to steps 2. But it doesn't matter, but I will not hit my cache before steps 1. This is, at least for my input. But, putting this aside, I have my cycle length, cycle lines removed, I have my my steps left, and I want to know how many full cycles I can fit in my what is this? How many cycles I can fit in my steps that I left. I need to. And probably, I think there is some smart math or smart trick to figure out how many things I would add on this this tail, which I would get with left percent cycle length. But I decided to not bother with that. I would just go and calculate this couple steps, because it would be at most cycle length to perform. So now we have this thing, which means that I can use my cache, and then I print this information, what is my cycle and so on. Or I was just curious, where did I hit it and how it works. So we can see this print. Obviously, if I test my performance, I can just go and comment it out. Doesn't matter. And what do I do now? I know that that after any multiplication of cycle length, I would remove the same multiplication of cycle and sum of, so I can just fast forward all those cycles in single step. And that's all I do. This is how I use my cache with cycle detection, right? And then if I reached steps 1, I just store my steps 1. Otherwise, I check if I am after steps 2, and then I just break, because I don't care about anything else. I print my results, and as you can see, my results are kind of quick. I reached my part 1 in some time, and then I reached part 2 right after that, mostly because I just hit my cache. I hit my cache on 2007 6.2 iteration, which is a bit above 2022. Cycle length is 1700. It is not a surprise that it is longer than my first occurrence. I mean, the cycle started on around right after step 1000, because first you needed to build up this initial structure, right? And yeah, this was solution. One thing I want to play around just quickly. I don't want to do too much. I would keep my bottom. I'm very curious if it would affect the performance in any way. So what is bottom? Whenever I use my surface, I would use it starting from bottom. I would just not, I would never cut the surface, because I think that because I know where that my cycle is, that is detected before 3000, so the vector will be 3000 height, and right. It makes sense that I maybe never need to shrink it. Instead, I would just ignore it. Bottom lines. Maybe I don't even need to do that. Maybe there's a better way to do that. This. Oh, this is a drain. So here I just do remove line. I don't do that. Remove lines. How many lines do I remove? Y plus index plus 1, I believe, because this its length is this is the last index, but length is 1 more, minus y plus index plus 1, and I do not drain. Removed line is my bottom, right? Yeah, I don't need to keep my bottom. Removed lines is my bottom. if I'm not mistaken. And no, I mean, I'm often mistaken, but not this time. I need to resize it. Yeah. For now, I think I would never need to call it, but I mean, I think that calling it, I can make it free. Those are just funny micro optimizations, so yeah. Sorry, I need my surface. It's already shrinked. Removed lines, surface, removed lines. Yeah, those are all of those. I'm wondering if it works. Once and for some reason panics. Hmm. What? Ah, that's funny. After I detected cycle, I jumped up. I removed my lines, but I didn't make my head bigger. So I need to track bottom actually, because it is a bit different than removed lines. So it's bottom. I mean, I can still avoid shrinking the vector. I think I need to push this. Yeah, this should work on removed lines. Sorry, where do I shrink it? Here I need to also shrink bottom. I mean, extend bottom. Here I am working on removed lines, but not on bottom, so I do not go higher with bottom. Yeah. You can see that this happened because my vector is only this high, and yeah, this is where is how many lines I want to analyze because of my skip. Why I want to allocate this many lines? Wow. This resize. A bit faster, and the last thing I can make to improve on that is to never resize. And to never resize, I can make the surface be big enough to have my whole thing in memory, and I know how high I go. Roughly 5000 should be good. Go with never resize. So I never need to resize right now. What happened? I mean, I think I know what happened, but I don't know why it happened. Is surface ever shrinked? never remove lines. Or is my thing still too small? Yeah, my thing was just too small. But I don't think it did improve. Yeah, it didn't. It got even worse for some reason, maybe because of some, yeah, it was just noise. Maybe it improved a bit. Didn't run enough, but I'm still curious if this would improve. So now I try to completely avoid keeping it on the heap. I still need to use heap for states. I probably don't need to, but I don't. I'm too lazy to check another approach. But yeah, this doesn't change anything. So, I mean, back then, I remember that heap was like way faster than stack. Now it's not so much difference. But why do I say that this removing thing is so expensive and I demonize it this much? I mean, it actually gave us some improvement. If you think about that, we got some improvement with that. And why shrinking is not, or extending is not. So here what you do, while draining and removing, you are trying to remove low elements from your vector. So what you need to do is you need to copy elements, like, let's say this is your vector. 1, 2, 3, 4, 5, 6. Let's say this is your vector and you want to remove 1 and 2. So what you need to do is you need to copy those elements basically one by one. So 3, 2, 3, 4, 5, 6. Then 3, 4, 3, 4, 5, 6. And this is how you do this naively. Oh, 5, 6, 5, 6. And if you copied all of them, then you shrink the vector. Then you set its new length, because if you shrink the vector from top, you just change the length. You do nothing with elements. So this is how you move two elements. You can do it a bit smarter by, if you know that you're removing two elements, you can try to copy them two at once. So you can do like 3, 4, 3, 4, 5, 6. Then 3, 4, 5, 6, 5, 6, and then cut. It's way better, but it's still not good. I don't know if Rust does this optimization, but you can force this optimization by keeping, by doing it basically yourself, or by shrinking only if you went twice as much and manually copy the half lower. There is a trick, but there is another trick to avoid this kind of situation. You can keep two buffers, two vectors, and when you shrink, then you just copy from the other vector to the new to the other one, from the one vector to the other one, your elements. You can do it in one mem copy, and then you just swap vectors, so they swap only the metadata. And the only question may be why you cannot just in one take tell DRM to copy, you know, all the elements back. Because the DRM would copy them probably like still one by one, and it would overwrite position. And what would happen is probably something like this. You would end up with this 3, 4. Then in this case actually nothing bad happens. But I think that this is not allowed, because DRM, or maybe it's allowed, but I think this is not allowed to copy from from two overlapping memory in memcopy. I mean, I know this is unsafe in Rust, but I think that is basically not allowed in hardware. And this is basically the reason why this is way more expensive than removing elements from the end, so shrinking it or extending, because extending or shrinking just decreases the counter of length, and extending is also a bit expensive because expensive requires you to allocate new memory in some cases, and then but you can then copy all the things in one take, so yeah, not so bad actually. And as you could see, even extending, like making this value high enough, didn't actually improve the performance too much of the application, because this relocation would happen like once more. It doesn't matter at all. It's so fast that it won't happen. But this removing lines would affect your speed. And if I did this removal because I was sure that the tower would go more. I mean, I wasn't even thinking about taking cycles. Okay, but this was solution. That was explanation of them, kind of detailed because I'm happy about it. One thing. I think I promised you I will tell you how to make it less mutable. Basically, what you would do, you will keep it in some structure, and you would have helper functions on those structure which handles all of that, and it would maybe even work on, you know, on owned variables, but it would just perform all of that instead of doing it in place. It would, you know, be called on the functions to transform itself, and often you do that by basically having function like impl blah blah, and your function foo takes yourself mutably, right, and return itself, and you still just mutate yourself, and then you return yourself. That would be better for normal application because you very much define what you can change in which function can change your structure and what fields could be changed. I mean, basically fields or structure you cannot change any context. Here I have like so many crap which could change, and some of those doesn't even need to be kept. But you know, for puzzles, this is okay way of working. And see ya tomorrow with, I hope, a bit easier puzzle because Sunday I want to rest. Bye!